Modeling this as a Bayesian game, we have the players, the jurors are the players, and each player's vote, player's actions is vote to convict or acquit. And each player's preferences depend on whether the defendant is guilty or innocent, and each player's information consists of her interpretation of the evidence, so therefore we define a state to be a list X S1 to Sn, where X denotes the defendant's true status, true state. So whether they're guilty, in which case X equals G, or innocent, in which case X equals capital I. And Si, all the S's here, represent player I's interpretation of the evidence presented and whether it points to guilt, small g, or innocence, small b. And the signal each player receives is her interpretation of the evidence Si. So in any state in which X equals G, so the defendant's true status or true state is guilty, each player assigns probability P to others receiving signal G, i.e. everyone receives a signal saying that the player is guilty, and each player also assigns probability 1 minus P to others receiving signal B. This is all given that the defendant's true state is guilty, and in any state in which the defendant's true state is innocent, then each player assigns probability Q to others receiving signal B, and again each player assigns probability 1 minus Q to other jurors receiving signal 1 minus B. Sorry, that's stupid. To other players receiving the signal G. My bad. Okay? So in a state where the defendant is guilty, X equals G, each player assigns a probability P to others receiving signal G, so assigns a probability P to the defendant actually being guilty, so other players are also receiving the signal G, and assigns a probability 1 minus P to other players receiving the signal B, in which case the other player is receiving a signal that the defendant is not guilty, is innocent. And in any state in which the defendant is innocent, X equals I, each player assigns probability Q to others receiving the signal B, i.e. the defendant not being guilty, being innocent, and each player also assigns a probability 1 minus Q to others receiving the signal G. So in a state where the defendant is innocent, they receive the signal G with probability 1 minus Q. Okay? And each player cares about the verdict. And the verdict depends on the player's actions and also on the defendant's true state. And given the assumption of unanimity, which says that every single juror has to vote to convict in order for the defendant to get convicted, only the action profile where every single juror votes to convict leads to a conviction. Therefore, the player's payoff function is the utility of player I given their action and the state is equal to 0 if the actions of the juror of all the players is the action profile is not equal to everybody convicting, and the state of the world W1 being I. So 0 if every single juror, not every single juror chooses to convict, and the defendant is actually innocent. So this is correct. So acquitting the defendant when he's innocent. And it's also 0 if the action profile is unanimous. So every single juror chooses to convict, and the true status of the defendant is that he's guilty. And it's minus Z if the action profile is to convict, so there's a unanimous vote, and the state of the defendant is innocent, and it's minus 1 minus Z if the action profile is not unanimous, there's no unanimous vote to convict, and the defendant is actually guilty. Where W1 is the first component of the state which gives the defendant true status.